So, you're having a pretty standard Tuesday. The Earth is doing its usual thing, spinning around at a respectable clip, giving us sunrises, sunsets, and a reason not to float off into the cosmos. Nice, right? But what if it just didn't? What if instantly the Earth stopped spinning? Not gradually wound down like a tired toy. Oh no, we're talking bam, full stop. One moment you're complaining about the Wi-Fi. The next, well, things get energetic. The planet keeps orbiting the sun, mind you. We wouldn't want to complicate things too much by also careening into our local star. Small mercies. So what exactly would happen if our planetary merry-go-round slammed on the brakes with the universe's worst case of whiplash? Let's just say your plans for the afternoon would require significant revision. And by significant revision, I mean they'd mostly involve being abruptly converted into a thin layer of organic matter, spread very, very widely across the landscape. But we're curious. We like to know the details of our hypothetical doom. So let's put on our safety goggles, not that they'll help, and dive in. First, let's appreciate how fast we're normally moving, even when we feel like we're just sitting still, doom scrolling. The Earth spins on its axis once every 24 hours, give or take. At the equator, the surface is zipping along at about 1,670 kilometers per hour, or roughly 465 meters per second. That's faster than the speed of sound in some colder air, though not at sea level. This speed tapers off as you go towards the poles, where you'd essentially just be pirouetting very slowly. But for a significant chunk of the planet's population and landmass, we're talking serious velocity. Imagine your car instantly hitting that speed. You wouldn't even have time to spill your coffee. Now, instantly is a fun word for physicists because it usually means things break in interesting ways. If the Earth's rotation decelerated to zero in, say, zero time, the forces involved would be, well, infinite. The planet itself might not appreciate that kind of stress. It might, unplanet itself. So, for the sake of our thought experiment, let's assume some kind of magic happens. The Earth's solid body just stops rotating, perfectly, without the act of stopping causing it to fly apart into a gazillion pieces from the sheer internal stresses of such an impossible deceleration. The problem isn't the stopping, it's what happens next. This is where our old friend, Sir Isaac Newton, specifically his first law of motion, crashes the party. Or rather, everything else crashes because of it. An object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. The solid Earth has been acted upon by our hypothetical magic stopper. But everything on the Earth, the air, the water, you, me, that questionable sandwich in the back of your fridge, every tree, every building, every loose rock hasn't. So, while the ground beneath your feet suddenly has a velocity of zero, you and everything else not nailed down with cosmic superglue are still cruising along at up to 1,670 kilometers per hour eastward. Remember, we said the Earth keeps orbiting the sun. This is important. Our planet hurtles around the sun at an average speed of about 107,000 kilometers per hour. That motion is completely independent of its daily spin. So we're not suddenly going to become a rogue planet. We'll still have seasons, sort of. Ish. The main problem is that everything on the Earth is about to have a very, very bad day. Or rather, a bad few minutes followed by a very different kind of eternity. Okay. So the Earth stops. You, the atmosphere, the oceans, and a surprising amount of the loose surface material don't. Let's start with the atmosphere. It's now a global wind, moving at up to 465 meters per second relative to the newly stationary ground. That's well over Mach 1. Supersonic. This isn't just a stiff breeze. This is a scouring pad the size of a planet. Anything not part of the bedrock, and frankly a lot of the bedrock itself, is going to be instantly swept away pulverized, and carried eastward. Trees? Gone. Buildings? Atomized. Topsoil? Saya? Mountain ranges would be sand-blasted into smooth lumps in minutes. Humans? Animals? We become high-velocity projectiles. There's no surviving this initial phase. You wouldn't even experience it as being thrown. You'd experience it as the entire planet suddenly accelerating westward underneath you at hypersonic speed. The air itself would become a massively destructive force, denser than you might think when it's moving that fast. The friction between this high-speed surface layer of stuff, formerly known as civilization and nature, and the stationary planet underneath would be immense. We're talking about an unbelievable amount of kinetic energy being converted into heat. The surface of the Earth would become a global inferno. Rocks would melt. The air would superheat. It's not just the loose stuff either. The lithosphere, Earth's crust and upper mantle, isn't perfectly rigid. The sudden stop would impart colossal stresses. Imagine trying to stop a spinning bowling ball by grabbing just the very outer layer of paint. That paint layer, our crust, would shear, tear, and fragment. The largest earthquakes in history would look like gentle tremors by comparison. And all this material, now a high-velocity, superheated slurry of rock, air, and whatever used to be on the surface, would be flung around. Some of it, especially the atmosphere, might achieve escape velocity and be lost to space. And then there are the oceans. Oh, the oceans. Billions of cubic kilometers of water, also imbued with that eastward momentum. When the seabed beneath them lurches to a halt, the water keeps going. This isn't a tsunami. It's the entire ocean deciding to relocate eastward at hundreds of kilometers per hour. Coastal areas? Forget it. Inland areas? Probably also forget it. We're talking about waves that would make the Himalayas look like speed bumps, scouring continents clean down to the bedrock. This colossal wave would sweep across the land, carrying unimaginable amounts of debris. Then, like water in a brutally shaken bathtub, it would slosh back and then forth again, for days, maybe weeks, with diminishing but still apocalyptic energy. Eventually, things would settle, but not before reshaping every coastline and flooding vast swathes of what used to be land. Any idea of ark building is, shall we say, optimistic. A good portion of our atmosphere, especially the upper layers, would likely be ejected into space. The sheer kinetic energy of the initial eastward rush, combined with the intense heating from friction, would give many air molecules the kick they need to escape Earth's gravity. Our nice, protective blanket of air would get significantly thinner, very quickly. This has a couple of unfortunate side effects, assuming anything was left to experience them. First, less atmosphere means less protection from solar and cosmic radiation. Sunburns would be epic and lethal. Second, the Earth's rotation plays a crucial role in generating its magnetic field through the geodynamo effect in the liquid outer core. If the solid Earth stops, but the core, initially, keeps spinning due to its own inertia, things get complicated. But over time, without the convective motions driven partly by rotation, that magnetic field would likely weaken dramatically or even collapse. Hello, unshielded solar wind. Now, for the really big show. The Earth isn't a perfect sphere. It's an oblate spheroid, meaning it bulges at the equator due to the centrifugal force of its spin. This bulge is quite significant. The Earth's equatorial diameter is about 43 kilometers larger than its polar diameter. That equatorial bulge contains an awful lot of rock and, importantly, water. If the rotation stops, that centrifugal force vanishes. Gravity, now unopposed by this outward fling, would begin to pull the Earth into a more perfect sphere. This isn't a gentle massage. This is global reconstructive surgery performed with a sledgehammer the size of a moon. The crust would buckle, shatter, and rearrange itself on an unimaginable scale. Think earthquakes that register as all of it on the Richter scale, everywhere, simultaneously. Volcanic activity would explode globally as the shifting crust releases pressure on the mantle. New mountain ranges would be thrust up violently, while other areas collapse. The planet's face reformed. And what about all that water that was part of the equatorial bulge? Well, water likes to find its own level. On a non-rotating spherical Earth, that level means gravity pulls it equally from all directions towards the center. The result? The oceans would migrate. Water would flow away from the now too high equator and collect at the poles. We'd end up with a massive, continuous ring of land around the equator, a new supercontinent, and two enormous oceans covering the polar regions. The familiar shapes of our continents would be gone. Coastal cities? Most would either be hundreds of kilometers inland on this new equatorial landmass, or thousands of meters underwater in the new polar seas. If you happen to be at the equator, you'd find yourself suddenly very, very far from any large body of water. With the Earth no longer spinning daily, our concept of day and night gets a radical makeover. One day would now last an entire year. Well, half a year of continuous, unrelenting sunshine, followed by half a year of continuous, frigid darkness for any given point on the surface. The side facing the sun would bake. Temperatures would soar to hundreds of degrees Celsius, boiling off any remaining surface water and sterilizing the land. Meanwhile, the dark side would radiate its heat away into space, plunging into temperatures far below freezing. Think colder than Antarctica on a bad day, everywhere. This extreme temperature differential would also drive unimaginable storms along the twilight zone. The band between eternal day and eternal night, planet-circling tempests, if enough atmosphere remains. Remember that weakened magnetic field. It's not just bad for radiation levels. The geodynamo, driven by the Earth's rotation and convection in the liquid outer core, is what gives us our magnetic north and south. Without a robust spinning core system, that field would eventually decay almost entirely. Your compass would become a quaint, useless relic. More critically, this shield protects our atmosphere from being stripped away by the solar wind. Mars is a good example of a planet that lost its global magnetic field and subsequently lost most of its atmosphere. Our already thinned atmosphere would be further eroded over geological timescales, making the surface even more inhospitable. The beautiful auroras? A distant memory. Now, you might be thinking about tidal locking. Our moon is tidally locked to Earth, which is why it always shows us the same face. This happens because Earth's gravity has slowed the moon's rotation over billions of years until its rotation period matched its orbital period. Earth's rotation is also very gradually slowing down due to the moon's tidal forces. Our days are getting longer by about 1.7 milliseconds per century. If the Earth instantly stopped, would these tidal forces from the moon or even the sun try to get it spinning again, or lock one side permanently facing them? Yes, probably. Over immense timescales. The forces are still there. But the state of the Earth would be so thoroughly catastrophically altered that this slow gravitational dance would be happening to a dead, scoured, reformed, and irradiated rock. It's a bit like worrying about the paint job on a car hit by a meteor. So, to recap, if the Earth instantly stopped spinning but kept orbiting, the consequences would be thorough. First, everything not nailed down by the strong nuclear force gets flung eastward at supersonic speeds, scouring the surface. This generates enough heat to melt rock. The oceans follow suit, creating globe-spanning tsunamis that reshape continents. The atmosphere is partly stripped away. Then the Earth itself, no longer bulging at the equator, relaxes into a sphere, causing planet-shattering earthquakes and volcanic eruptions. Oceans migrate to the poles, creating a new equatorial supercontinent. Days become year-long cycles of extreme heat and cold, and our protective magnetic field fizzles out, leaving the surface exposed to harsh radiation. In short, it's a full planetary reset, and not in a fun, turn it off and on again kind of way. Is there any upside? Well, traffic on the commute would be significantly reduced. Permanently. And you'd finally have plenty of time to watch that really long sunset, like 6 months of it. Humanity, and indeed pretty much all complex life, would be instantly extinguished. Perhaps some extremophile bacteria, deep within the Earth's crust, might weather the initial trauma and the new harsh surface conditions. But for us surface dwellers who enjoy trivial things like, stable ground and breathable air at non-lethal temperatures, it's game over. So let's all be very grateful that the Earth is a reliable spinner, and maybe don't give any cosmic entities any bright ideas. Optional if you do spoken out, Rose. Thanks for watching. Don't let the existential dread get you down too much.